Hey, Chris. So this week I'm giving you an exploratory analysis. So this is how to do basic, just kind of just let's look at the data before we do any data science, any modeling, any other statistical analysis and on it. You really need to look at the data you have and kind of clean it up, understand a couple different things about it. So I'm going to go through this. I'm going to do what are called sanity checks, talk about those, do what's called univariate analysis, bivariate analysis, talk about missing values, how we treat them, a little bit of outliers as well. I'm also going to send you real quickly this second notebook, wherein make sure it's got that. Yeah. So this notebook, this is I'm going to send you this, and it's your project that I'm gonna have due um that first and the end of the beginning of March. So it's really an opportunity for you to go through and practice what we've talked about. So you're going to import, and I have some things, and I have some things where I'm telling you what I want you to look up. So you need to write the code and then give it. And I give you a couple things, and then what observations. So there's both a markdown one as well as ones for you to actually work on. So I hope that kind of gets you working on it. I just want you to work on all these different things. I can give you some feedback specifically, and I kind of how many points, marks I'm doing on each of these to kind of work your way through it, all those questions. And I broke it down by questions to make this a little bit easier, a little bit more clear to work on. All right, let's get back to exploratory analysis, and just keep that clear. All right, so we're going to look at some real estate data about the city of Melbourne, so in Australia. So just I gave you here in the beginning a description. This is common when doing analysis. You talk about what all the different categories are, like what each column is, and then what it is or key things. Like here, type is the type of property. It's a house. Is going to be an H townhome. Is T U is a unit or duplex, like an apartment. Seller G, that's a real estate. The date, distance, postal code, bedroom, car, etc. And also notice even on like land size, I put out that's in square meters. Distance is in kilometers. So these are some things just to be aware of as we're kind of moving forward. All right, so let's get into some sanity checks just to get started. I'm going to import the normal libraries, my NumPy, my pandas, and so forth. And this I'm going to tell it I want the floats to only go 3 decimal places, and so forth. So let's let's run that, and then let's import our data set, the Melbourne housing. And the first thing I'm going to do to kind of get myself started is I'm going to look at the head and the tail. So remember the head and the tail. The head is the first 5 rows. The tail is the last 5 rows. So I can sit here and just glance around and look at this example, and I can see like Airport West, Albert Park, Alphington, seller names, some dates, distances, slide over, and already I can see right here, inf and nan, which are going to come back up, and we'll talk about these more. Nan stands for null value, not a number. And I can see that there's already a couple different things going on here. And just kind of look, it's always good to just get this and look at it. What are you seeing just in your first quick analysis? Is there anything that pops up that sends red flags? If not, don't worry about it. This is more of just a way to see what it looks like. You can kind of have an idea of different concepts and other things like that. Now let's get in the shape. So I'm actually going to ask the shape of it. Remember, shape is asking, it'll give you 2 values. The first one's the number of rows. The second number is number of columns. This is a very easy way to have it already print out the number of rows and columns. And then this is where it gets fun. This is where, I mean, that should make sense. I got 16 columns where I listed them all the way back up here. Boom, all 16 of those things. And then also the number of rows. And if you notice, this is 27,113. And remember, it's one more than that because it has a 0 row. Always throws me off. I have to keep remembering that. Now let's look at this. This is gonna give us some key information. Now we did this previously and we kind of glanced at it and then moved on. Didn't mean much. Now it's actually going to tell us some key information. So suburb, as we saw up here, the suburb is a bunch of strings. So they're objects. That makes perfect sense. And it turns out there's no missing data. They're all non-null values. That's great. Okay, so we got that. Rooms, also nothing missing. It's an integer. That makes sense. The type of home is a string. Makes sense. Seller, string, good. Wait a second. This has date as a string, as an object. So what that means is I'm going to have to convert that from a string into a date. And that's kind of the key idea that we're gonna have to mess around with here. Distance is a number. Now this is the key thing. Notice it has the postal code as a integer, as a numeric value. Now that's a key detail because really this is more categorical than it is an actual number. This happens quite often. We're not doing any actual analysis, but if I was trying to do like a linear regression, I don't want it to be using this as a actual number. I'd have to do some categorical value instead. Continuing down, bedroom is a float, car, bathroom, those are all float 64s. And right there, that's a little bit weird. I'd expect those to be more integers than floats, just because you can't have like half a bedroom, but yeah, I guess you could if you depending on how you want to do stuff. Land size, float, building area, object. Wait a second. I expected that to be a number. And so already I can see that that's another thing, as well as see there's only 10,000 non-null objects here out of 27,000 possible. That's a lot of missing data. We'll come back and talk about the null data later. And so this idea where we kind of glance through here and see what are some different things, where are some areas. So like this first one, this building area, that tells me that's something that's a real red flag. I need to go back and I need to find out why that is and then kind of fix it. All right, so we can already see that we have several numerical categories, some object categories. Date, we need to change it. So let's come here and we can use the dot to timed date. And then, but you have to be careful. You need to enter in this format. Which format is it? Is it day, month, year, or is it year, month, month, day, year? So this is Australia. And if you come back and look, 30/9/2017. That's obviously it can't be 30th month. So that has to be the date first, which is common in European and Australia. So we need to make sure you put this in. If you don't do this right here, it will throw, I'll just show you right now. If I try doing this, and again, I'm saving it into the date column. So I'm just going to delete this real quick. Run that. And see, it throws an error because it's like, I can't do that. And it doesn't like that. But I put that in and then it easily changes it. Now, let's come here. Let's find out what's going on with the building area. Because remember, it had a object, a string, when it should be a number. Well, this dot unique is going to kick out all the unique values that are in that column. So even numerically, it's going to only kick out the numbers. Well, if I look at this, I can quickly see that has an infinite, that doesn't make any sense. It has someone typed in missing, so they didn't have the data. And also see the nan, which means it has a null value. So I want to get rid of this int and this missing because those two, they are the same thing as the null. So I might as well go ahead and simply, and I'll just show you. I told it how many are there of each ones. Notice floats as the majority, there's some strings. And these string values, we now can be like, okay, what are the string values? And going back through here, we can glance through this and quickly realize all the string values are those two, the missing and the int. Though it might categorize a number as a string as well because it doesn't know any better. So by doing this apply type value counts, it simply does the types. And value counts is counting up how many of each of those. Now let's come here, and this is a cool way to replace a nan. So if I do replace, and I put in the things I want to replace, I want to replace anywhere it says missing or infinite in the building area column with an np.nan. This right here is going to use NumPy and put a null value in there. And then though, but if I do that, I then have to make sure that everything else goes in as a float because I want it to be, I don't want it to be a string. I want it to be a number. So let's make it a float. And so I still have to change everything back to a float. like such. Now if we do that, now we come down here and notice building area is now float form. So that's good. It's fixed that one little detail. And it turns out if we go back, the number of non-null values before, so this is now 10,529, whereas when we did it before, it was pretty much the same value. Notice it's a little bit different. It was 10,543. So a few more values became null, and that's just because some of the missing values, the ones that were missing and so forth, are now classified as null. Some of the, remember up here, we had a whole bunch of strings. Turned out some of those strings, if we actually did a little bit more investigation, we would have confirmed that all the other string types actually were just like this 129.92. It just doesn't know how to read that. It's really, really kind of confused. So we have all these things. Now there is actually another way to deal with this. I could have, if I had known in the first place that there were missing values, that a few places someone typed in missing or typed in inf, I can put in, when I read in the original CSV, excuse me, I can do NA values and then this, and that will literally go through, and what it will do is it will go through the entire thing and turn anywhere in the entire data frame that says missing or inf into a null value, a nan. Now, if we do this, come quickly, you'll see that data type is still float. But I want to point something out. This only works if I already knew ahead of time. And so it would have saved me the opportunity of doing, instead of doing two parts, I would have been able to do it with a single step. All right, so that's one of the major things in here, is we can now swap out something with a null value. There is some other replace when we were dealing with null values, but since in general replace, I tell it what I want it to replace and what I want it to replace it with. All right, so let's come down here. Let's look more at these missing values. So now we've created a bunch of missing values. How many are in each of them? So before we had the number of non-nulls, so we could have just counted those up. But this one right here, so this first part is going to create essentially how many null, and then it's going to add them up by column. Because remember, if it was null, it'll give it a 1. If it's not null, it'll give it a 0. So it just adds up all the not null values, so it can give me that number. And quickly it tells me that suburb has 0. There's no missing value in suburb all the way down to date. There's one missing value in distance and postal code. Okay. And then I have bedroom, bathroom, and car all have about 6,000. Land size is about 9,000. And now I got a couple of really big missing things right here in building area and year built. So if you look, there's these 8 columns are the ones that have some missing data. And what we're going to need to look at this a little bit later on when we treat our missing data. This is going to come back, but this is something we really want to look at, is why is there missing data and so forth. Another key thing we want to look at whenever we get a data set is for duplicates. In other words, did anyone create the same entry twice? That's obviously a problem because it's just adding anomalies. So it's literally looking for how many rows are completely identical. And there's 11 rows that are identical. Okay, that's a problem. So I'm going to tell it to actually go ahead, or I should say there's 11 rows that are identical. There's 11 rows that are a duplicate of another row. So it's going to come in here, and this drop duplicates is automatically built in place. Remember, I can do this, or if I don't want to use the in place, I just do data equals data.drop duplicates. So you can do either one. And then this one is going to reset the indexes, because remember, if you don't reset the indexes, it just drops them but doesn't change the indexes. So there's an extra column with that. So if we run this and then hit describe, now we're looking at all of our data and what that really looks like. So again, how many count? Notice that all of these have the same count, except distance and postal code are missing. So this is only going to do this for in this particular set, it's set up to only do it on the numerical values. Again, depending on what you do it on, it may actually run it on categorical data and just have null values and other things like that. But it prefers to do this and prefers to do it for mean, the median, the mean. And that, again, that doesn't mean a whole lot in terms of time. I mean, the date. It's in date time form, so it actually can tell me what is the mean time. The minimum time would be 0. And this is all kind of interesting. So the max, in other words, the last date in there is March 17th, 2018, with the first date being January 28th, 2016. So it's over a 2-year period. It puts this right in the middle. This is also, this is the 50%. This is the median right here, is the 50 percentile. And then we skewed up. And the standard deviation doesn't make any sense when you're trying to calculate that, but it does make sense in the other categorical variables and so forth. So this, you can do this as a quick glance at it. Let's just, here's some data out here, kind of some summaries of some things you can pull out of there. So let's just look at rooms. The mean is 3 and the 50%. So that means that on average, we have 3 rooms or less. The biggest house has 16 rooms. That's a really big house. I'm gonna need to come back and look at that a little more. That seems like strange. A 1-bedroom house, that makes sense. If there'd been a 0-bedroom house, we need to talk about that. But again, bedrooms are also at 3. Bathrooms are about 1.92. There is actually some places with 0 bathrooms and 0 bedrooms and 0 cars. I mean, 0 cars makes sense if you're talking apartments. Bathrooms and bedrooms 0, that seems weird unless it's a studio apartment. Doesn't classify it as a bathroom. I don't know. It also could be a blank property. Actually, literally is nothing built on it. Building size, smallest is 11. Building area is 11. This, remember, this is square meters versus this, which is 6,700 square meters. And again, we look at this price. That's a really big sell value. It's 11 million. Yeah. So that's kind of an outlier. We'll talk about outliers a little bit later on. We can go through and break this down by category and just kind of look at what are the averages, how's the average and the median. 2 big things I usually look for when I glance at this is I first look at this first category, the mean and the median, and how do they compare? And so in like the first category, they're very close. Distance, they're pretty close. Postal code, okay, I don't care what postal code, it doesn't really matter. Bedroom, close. Bathroom, there's a big discrepancy. And part of that is this 9-bathroom home that's throwing that off massively. Car, 1.7 and 2, it's a little bit off. There's an 18-car home. Again, are any of these really, really big and kind of weird? Many of these are pretty close, but when we have outliers, we'll get to this later, it really is going to affect the mean, but not so much the median. So that's why you're going to see the mean being pulled up or down based on outliers. So that's why we look at outliers. So like year built, it has these being pretty darn close. But it does have, and that makes sense, it has a, that's interesting. We'll talk about that one. 2019, year built, but the date on sold be 2018. Okay, that's really weird. We need to talk about that one. All right, so there's a couple things in here that's kind of weird. So postal codes. This is telling me how many N unique is how many unique values we get in postal codes. 209. Okay, so I have 209 different postal codes. Now let's do a little more. So I'm going to create an array here of all the different columns that are categories, cat columns. This is very common. Even when you go on and do some data science modeling and so forth, you often want to do categorical columns and something here. Now I'm going to do this something fun. I'm actually going to call a for loop where it's going to call each of these columns and it's going to do a value counts for that specific column. So it's going to break down how many there are in that category. And then this line is just going to add a bunch of dashes between them so that I can really see the breakdown. So you can see like right here is the break. So I have this first part is suburbs, and it even tells me that it's a count. There's 345 possible values. They're int 64s because we're doing a count. And then it breaks it down. So reservoir has 721, whereas Viewbank has 1. Housing types, we can already see there's a lot of houses, especially compared to units and townhomes. Sellers, highly distributed, and region names. The regions are, you can see a massive discrepancy. The metropolitan, those are really big values. I mean, even if I'll even include this southeastern metropolitan, and then there's a massive drop off. These are all way less than 1,000. I mean, capped at 165 versus everything here is over 1,000. So that's a big jump. Victorian is totally different category than metropolitan around Melbourne. I don't know Melbourne well enough to know anymore. But I can also add this. So this, when I did this, I did as value counts. I can come down and do the same thing, except I had normalize equals true. And what this does is actually, it's kind of fun. Now it actually breaks up and tells me what percent is in each category. So if reservoir had point, well, I should rephrase that, has 2.7%, because remember, this is in decimal form, this is not as a percent. So it's 0.027 is 2.7%. On the other hand, notice that Viewbank and Montrose and so forth have 0. That's just because they each, remember, they only had 1 value. If we come back up here, they all had like a single values in them. And when you take that divided by the total number of values, it's just way too small. Again, coming here, we can see that 68% of the properties are houses. That's huge, whereas only 10% are townhomes. Again, there's quite the distribution from 10%, Nelson at 10% of the sales, versus like Icon, which had 1 sale. The metropolitan, again, we saw this before, but these 3 are crazy tiny because they're all less than 1%. Whereas the metropolitan, you have this one at 5 east, and then all these others are at 12, 21, 28, and 31%. So there's a lot of stuff in the metropolitan and very little. In fact, we could say that there's a total of 1.5% of the total properties are in Victorian. So that's after, remember, we dropped the duplicates. So that's kind of a big deal that we have all these things. And so I typed that up down here. The highest number of properties are in Reservoir, followed by this, because that's actually a big, again, this is coming back up here. It's a big drop off to go from 724 to 493. So I like to look for big drops. Again, even here, we saw 2.7 versus 1.8. So it's 1.5 times as big. That's pretty big. Most of the properties are houses. We already talked about that. I can tell you who the top 5 sellers are. Simply come back here, boom, 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 and as lowest 5. And then 31% are in the metropolitan, whereas we talked about that not very many in the Victoria areas. And that kind of gets us going. All right. I'm going to go ahead and stop this video and make a second video on univariate analysis for you.